I've added in some really cool distortion on some of my slides, so I hope you enjoy that as we go through. Definitely intentional, really excited about it. So I'm Jess. I'm a software engineer at Scan.com, which is a medtech startup. Huge shout out to Scan.com. They gave me the time and resources to be here today, so I'm very grateful. And yeah, so I created this talk after I volunteered at a Rails Girls event in London. The women I was paired with had a lot of great questions about what we were building. Some I could answer, and some I couldn't. So that made me want to dive deeper into Rails, specifically ActiveRecord, so I'd have some more answers the next time around. I'll be telling the story of my learning through the fictional character Zoe. She was a person who didn't know anything about Rails, and I wanted to make this talk approachable for all the junior engineers that are here today. So we'll be starting from the ground up with little assumed knowledge. Just to show of hands, if you've been a software engineer for more than 3 years. Okay, I just want to memorize your faces, so no zoning out, even though we're starting from the ground up. There'll still be some tidbits in here for you as well, I'm hopeful. But also just really look at it from a mentor's mindset. Think of the more junior engineers that are on your team. How might you help them discover new areas in the code base, or maybe some of the parts that you take for granted as knowledge that maybe might still be new for them. So, without further ado, this is ActiveRecord Unveiled, mastering Rails as ORM. And don't worry if you're not sure what object relational mapping means, we will get there. This is Zoe. She's learning to code and attended a recent Rails Girls event, where she went from knowing nothing about Rails, very little about code even, to building an entire web application, all in one day, with the help of a mentor. Rails Girls has a really handy guide that Zoe followed, and the code that we'll see today is the result of her time at the event. Rails, Zoe learned, was a web application framework that's written in Ruby and designed to help software engineers quickly build and maintain web applications with minimal configuration. Zoe used the command Rails new with the name of her app, Rails Girls on 8, to create her entire Rails application. And then Rails generates scaffold to create a model, view, and controller for her ideas. There was some other code involved too. She used the carrier wave gem to be able to upload a picture, and she used Bootstrap to improve the styling. But overall, Zoe was really impressed by how little code she needed to write, with Rails magic doing so much for her. By the end of the day, she could create a new idea with a picture, she could edit her ideas, and she could delete them too. When she was done creating and editing all her ideas, she could see them listed on her index page, in case she ever needed inspiration for what to do next with Cody. But where did those ideas live? Zoe did a search that looked in every file in her application, a global search, but she couldn't find the words, recreate scene from The Lion King. It turns out that information about her ideas is stored in a database, and that her database was a relational database. It's also like, a database is like a digital filing system that allows Zoe to store, organize, and retrieve information efficiently. Zoe's relational database is stored very similarly to a spreadsheet, using columns and rows to organize the data. A relational database provides access to data points that relate to each other. Zoe only has one table at the moment, but she has visions of expanding her application, of being able to filter her ideas using different tags. Her relational database could enable her to do this. She could create a tag table that has all of the words she wants to use for filtering. But that doesn't help her quite yet, because the two tables don't relate to each other. She would need to create a join table, an idea tags table, that stores the IDs of all the records that relate to each other, hence the name, relational database. The first entry in her idea tags table has an idea ID of 1, which is exercise Cody, and a tag ID of 2, since it's an outdoor activity. The next two entries both have the same idea ID, which is 2 for recreate scene from The Lion King, but each has its own individual tag ID. Tag ID 2 is appearing for the second time because it's also an outdoor activity, with the last one having a tag ID of 3 for training, because there are actually a lot of sheep around making a lot of sheep sounds. So it's incredibly difficult for the Old English sheepdog to stay still on top of the giant rock. But how does recreate scene from The Lion King get from her database to her shiny new website? Zoe continued her learning and discovered that her database was a SQLite database, and that something magical called ActiveRecord was allowing her to interact with her database in her favorite language, Ruby. ActiveRecord, Zoe learns, comes out of the box with Rails, so it's been there all along, working in the background, acting like a bridge between her Ruby code and her SQLite database. To talk about ActiveRecord, Zoe learned, is to talk about object relational mapping, or ORM for short. So, Zoe concluded, object relational mapping, or ActiveRecord, is basically like a translator. Zoe gets to write her Ruby code. ActiveRecord does whatever it does need to do to get that information from the database, and then hand it back to her in a format she can use. Zoe's already seen this in action in the console. If she wanted to see all of the ideas that she has in her idea table, she could use idea.all, and they'd be output in a really nice, pretty way. One might even say they've been pretty printed, which the comment in the SQL statement reveals is the case for PP. Zoe can do other things with her ideas, like check its class and see it's an ActiveRecord relation, so ActiveRecord's already clearly hard at work here. And she can count her ideas or query them using where. These are both examples of reading from the database, but ActiveRecord also lets Zoe create, update, and delete her ideas too, which she's already tested out in her website. Zoe notices the SQL output in the dark blue text. It's a clear view of what the database is doing in response to her Ruby code. ActiveRecord takes her Ruby commands and translates them into SQL queries, which makes writing complex operations a bit easier to write and understand. Zoe decides to dive a little bit deeper into these, and she sees that the first part of it is saying how long it took to do the query in the database. In this case, it took 0.3 milliseconds. Zoe only has 2 ideas at the moment. She's building on them. But this is a good number to keep in mind as your application builds, because you don't want it to get too high. The next thing she sees is a SQL query. She doesn't have time to dive into what a SQL query, all the SQL query logic. So she creates a little to-do list for herself and adds learn more about SQL onto that list. Next, Zoe sees that comment that's saying we're going to output this prettily using pretty print. Then it says limit 11, which means there'll only be 11 records that are output, even though Zoe only has 2, so that's fine. And lastly, the SQL query has been tagged with the name of the application, Rails Girls on 8. Which can be really handy if you're looking for a particular query in logs or in a monitoring tool, like AppSignal, who's very kindly sponsoring this conference. This is great, but Zoe wants to know how ActiveRecord works within Rails. She identifies 4 areas in her code base that she wants to explore: gem file, default configuration, database configuration, and model creation. She decides to start with the gem file, but before heading to her gem file, she wanted to confirm what exactly a Ruby gem is. A Ruby gem is code that's been written for a specific purpose that anyone can use in their application. In fact, when Zoe used the command Rails new to create her application, a bunch of gems were automatically added to the gem file by default. RubyGems.org is a site where you can find, install, and publish Ruby gems, just like it says on the site. And Zoe learns that anyone can create a Ruby gem. So she decides to create one herself, make a really good domain name so that no one can ever use it ever again in the future, even if she doesn't touch it for 10 years, and then post it on that site for everyone else to benefit from. Zoe pops into her gem file, and the first thing she notices is the source on line 1. This means that all of the gems in her gem file will be retrieved from that website, the site she was just on. It also means that she'll need to be connected to the internet if she ever wants to update her gems or get a new one. Zoe finds the Rails gem on line 4 and sees that it adheres to semantic versioning, where each version number consists of 3 parts: major 8, minor 0, and patch 1. Zoe heads back to the rubygems.org site to see what her particular gem looks like. When she scrolls to the bottom, she sees all its dependencies. Each one of these dependencies is its own Ruby gem, and a bunch of them are a component of Rails. The one Zoe's most interested in is ActiveRecord. So when Zoe uses Bundler to install her gems, she can expect a version 8.0.1 to appear in gemfile.lock. gemfile.lock keeps track of all the Ruby apps that are used in her Rails application with the specific version for each one. There's a lot going on in gemfile.lock, so Zoe does a quick search and finds the first instance of ActiveRecord. Surprisingly, though, the version here is 8.0.2, not 8.0.1. Thinking she might have misremembered, she heads back to the gem file, but confirms it's definitely 8.0.1. But what she missed the first time was the tilde and greater than sign. This means that Rails can use any version that is greater than or equal to 8.0.1 without going into the next minor version, the second number. So 8.0.0 would never appear because the last number, the patch number, is too low. 8.0.2 could appear, which is what it currently is, but 8.1 would never appear because the minor version, the second number, is too high. That explains why there's a difference between the gem file and gemfile.lock. A quick look back in the gemfile.lock, and Zoe understands its importance. When she used Bundler to install her gem, Rails version 8.0.2 was used and saved in gemfile.lock. So if anybody wants to collaborate with her on her Rails Girls app, and really, who wouldn't, they can use Bundler to be working off the exact same Rails version, even if the collaborator is using a different Rails version in a different application. In Zoe's exploration of the gem file, she learned that the Rails gem is automatically added to the gem file when she ran Rails new, because she didn't add it there. The Rails gem has a bunch of dependencies, and one of them is ActiveRecord. Even though ActiveRecord isn't listed in the gem file, she knows it exists because she saw it in gemfile.lock. That's gem file checked off the list. Up next is default configuration. And for this, Zoe heads to application.rb. She hones in on line 3, require Rails/all. Rails, Zoe knows, is a modular framework composed of various components. And she recently saw that each one of those components is its own Ruby gem. Each one of those components is responsible for a different aspect of web development. For example, ActiveRecord for database interaction, which is all Zoe's really interested in for today. Active storage for file uploads and attachments. Action mailer for email handling, and a bunch more as well. Zoe learns that you could, in fact, omit that line of code if you only wanted to use a couple components, but by default, you get them all. Zoe's feeling investigative today, but she can't seem to find the all file in her Rails application. It turns out, to find Rails/all, you have to go right to the source, the Rails source code that is, and look for a file called all.rb. Here, Zoe sees all of the components written as strings inside an array. Each one of these strings maps to a folder in the Rails codebase, and inside each folder is either a rail tie or an engine file. The one Zoe's most interested in is on line 6, ActiveRecord/rail tie. So Rails will go through all of the components, and for each one, require the rail tie or the engine file. Zoe follows the trail because, investigation's fun, and ends up in ActiveRecord's rail tie file. The rail tie is what's responsible for connecting the component to the rest of the Rails application. The code in railtie.rb sets things up so ActiveRecord can hook into the boot process and generally play nicely with the rest of the application. Zoe sees require ActiveRecord, and this is what loads the core object relational mapping, ORM, functionality that Zoe uses on the daily when interacting with her models and associations and queries. So it all started in application.rb, where Zoe saw the line require Rails/all. This is Rails' way of saying, go ahead and load all of the framework's modular components, ActiveRecord, Active Storage, Action Mailer, go ahead and load them all. Then Zoe ventured into the Rails source code into all.rb, where she saw that all of the components are required using a rail tie or an engine file. Still in the Rails source code, she followed the trail into ActiveRecord's rail tie file, where she saw require ActiveRecord, which loaded all the ORM logic, everything that makes ActiveRecord. By having the line require Rails/all in config/application.rb, Zoe's loading ActiveRecord and all the Rails-specific set of code she needs for it to work in her Rails Girls app. 2 down and 2 to go, it's on to database configuration. And for this, Zoe heads to database.yaml. This file, Zoe learns, is really important so that ActiveRecord can talk to the database. she sees that it's divided into different environments: development, test, and production, though she could change these keywords, and she could also add some or take some away. There's also a default section, and Zoe sees that each of her environments are inheriting their configuration from the default. Actually, the only unique attribute they have is the database name. Zoe sees that the adapter keyword on line 8 is specifying which kind of database her application is to use. Zoe's out-of-the-box Rails setting is using SQLite 3, but she could come back here if she wanted to change it in the future. For example, if she wanted to use PostgreSQL, she would use the PG gem, or if she wanted to use MySQL, she would need the MySQL 2 gem. She does see a comment above that says she'll need to have the SQLite 3 gem installed to make sure this all works. A bit panicked, she returns to her gem file and confirms that she does indeed have that gem, which makes sense because her application worked. SQLite 3 is another one of those gems that's automatically included in the gem file when you run the command rails new. Zoe decides to add pool and timeout onto her learn more about this later to-do list and heads to the database keyword on line 14. In her development environment, the database is stored as a file locally. The database keyword specifies the path to the database file. A look in her storage directory reveals that she does indeed have that file, but it seems that VS Code is unfortunately unable to open it. But that doesn't stop her from trying anyways. Seems like this file is a whole lot of nothing, or a whole lot of null, to be a little bit more specific, that just keeps going. She does eventually spot some familiar words: create table, idea, name, picture, description, and eventually, after even more scrolling, she spots the word she was looking for before: recreate scene from The Lion King. Zoe decides she needs to figure out what's going on in the file, so she hacks in, or at least that's what it feels like she's doing. Armed with commands from ChatGPT, like we all do, she changes directory into storage and starts a SQLite console to dive into development.sqlite 3. It worked, she's in, so we should probably consider a career as a hacker. Now that she's in, she writes a command to see all of the tables that exist in her database. Interesting. Ideas, that makes sense, that's the table she created. Schema migrations, okay, we've seen these words before. But AR internal metadata, that's a new one. Resolving to stay on track, Zoe gets ChatGPT to come up with the command for printing out all the ideas from her table. And she does reflect that if she was in the Rails console, idea.all would be a little bit nicer to write. Yep, those are all the ideas, but they're not printed as prettily as they were before. Since she's already heard of schema migrations, she decides to see what's going on in there and is pretty underwhelmed by the result. It's just a number. She does think she's seen this number before, though. When she ran the Rails generate scaffold command, this number is actually what is at, there we go, the beginning of the file name. On closer inspection, it seems that this number is actually a timestamp for when the file was created. Year 2025, March 14th at 10:39 a.m. and 21 seconds. At least Zoe has an alibi for that day. Someone actually accused her of doing some hacking then. Since there's only one table left, she decides she might as well take a look in AR internal metadata. She writes the command to output its contents and doesn't really understand the results. She adds learn what AR internal metadata is onto that learn to-do list because, you know, we got to stay on track, and heads back to database.yaml. Zoe realizes that even though there's nothing ActiveRecord specific in this file, it is crucial for making sure that ActiveRecord can connect to the database. When her Rails app boots up, ActiveRecord will read this file to figure out which adapter to use, like SQLite 3 in this case, which database to connect to, like development.sqlite 3 for development mode, and other important connection details too. That sums up database configuration. And there's only one more topic left, model creation. And for this, Zoe dives into application record.rb. But first, let's review what Zoe did at the Rails Girls event weekend. She ran the command Rails generate scaffold. Oh, I feel like my distortion's getting better and better as this goes on. It's excellent. With the table name idea and the attribute names with their types: name string, description text, and picture string. The Rails generate scaffold command created her a migration file, which she's already taken a peek in. A migration file tells Rails what changes to apply to the database. In this case, creating a table called ideas with the name, description, and picture attributes, and also some timestamps. At this point in the flow, at the Rails Girls event, no changes would have been applied to the database yet. So Zoe could have made any changes to this file that she wanted to make, if she wanted to add, say, another attribute. Then Zoe ran Rails DB migrate, and Rails did some magic, and all of those changes were applied to the database. But how does Rails know if it should apply to a change to the database? Turns out it's not magic at all. It's actually the schema migrations table that's in charge of this. When you run Rails DB migrate, Rails sees if the timestamp from the migration file is already in that schema migrations table. If the timestamp is already in the schema migrations table, then Rails knows it's already done its work, so it doesn't do it again. But if that timestamp is not in the schema migrations table, then Rails will apply those changes to the database and then add the timestamp. So Zoe ran Rails DB migrate. Rails saw that the timestamp in her create ideas table migration file wasn't in the schema migrations table. It created an ideas table in the database and then added that timestamp onto the schema migrations table. Because Zoe used that very handy Rails generate scaffold command, Rails also created her idea.rb in the models directory, and a bunch of other files as well, but she's not concerned about those today. Zoe heads back into her Rails Girls application in idea.rb. She did add in some bonus code at the end of the weekend. She wanted to make sure all of her ideas had a name, and she didn't want to accidentally repeat herself. So she added in presence and uniqueness validation on the name attribute. Zoe sees that this class is inheriting from application record. This means that Zoe's idea class will get access to all of the methods and the logic that application record has. Kind of like a puppy inheriting traits from a parent. Application record is the only other file in the models directory, so an easy win for investigation this time. In application record, Zoe doesn't feel like the idea class is gaining that much from its inheritance. There's not a whole lot going on here. She sees that application record is an abstract class, which means that she would never call application directly, but rather inherit it from other classes, like she's doing with her idea class. For example, Zoe would never do applicationrecord.all in the Rails console in the same way she early did idea.all. Well, she did do it because she's investigative, but the results weren't great, and she was informed that there was no such table. Application record, Zoe learns, is the base class for all of her models. So if there's ever any logic that all of her models need, then that could potentially go in this class. The only other thing that's happening in here is some inheritance. But it turns out it's a pretty big deal. This inheritance is what turns what would have been a regular old Ruby class into an ActiveRecord model. In Rails, ActiveRecord base provides the core functionality for interacting with a relational database through ActiveRecord. Magic happens in ActiveRecord base, or at least a lot of really cool code that's easily accessible to all of us on GitHub. It's back to the Rails source code to do some investigation. In the Rails source code, which is starting to feel like it's an extension of her own application, Zoe sees that ActiveRecord base is a relatively large file at 337 lines, with a lot of files being required. There's a lot of lists as well. There's a lot of things that are included, a lot of things that are extended, and Zoe's feeling a little bit overwhelmed by the list, so she decides to hone in on something familiar, validations. She did include that presence validation in her own idea class, so she decides to find where in the Rails source code that code is. After all, the Rails source code, though at first a bit magical and mysterious, is really just code written by other humans. Or AI. One can never be too sure these days. Back in the Rails source code, she finds validations.rb, which is the one that's included in base.rb. In validations.rb, Zoe doesn't want to get too sidetracked, so she adds come back to learn more about validations.rb onto that to-do list and does a search for the word presence. Presence, she finds, is at the end of the file, and this too is being required. Presence.rb is located in the validations folder. Presence.rb is the end of the line. Made it, Zoe thinks. She has a read through the code and skims the comments and is surprised at actually how little code is written in this class. It's almost as if it has like one single responsibility, a concept some of you may be familiar with. This is great. This Rails source code is great. But Zoe wants more control. She wants to see it in action. She wants to test it out in the Rails source code, in the Rails console, sorry. She decides to try to create an idea with the name of nil, which shouldn't save to the database because of her presence validation. She's using the create method with an exclamation mark, which is also referred to as a bang. And this means that ActiveRecord will report back to her if there are any validation errors. She runs the code, and like an overeager engineer, skips all of the output except for the final line. Validation failed, name can't be blank, ActiveRecord invalid. But Zoe is feeling investigative today, so she decides to have a little look through from the top. Transaction begin, immediate transaction. This is a solid mix of ActiveRecord and SQL working together. ActiveRecord has wrapped her create method in a database transaction. This means that either everything will be saved to the database correctly, or nothing will be saved. No half measures here. So the database transaction begins, and it does so immediately? Not quite. Immediate is the part where SQL comes in. Immediate means that no other transactions will be able to no other transactions will be able to connect and write to the database until Zoe's database transaction is finished. So if Zoe's in the Rails console and she's midway through creating an idea, but then someone tries to simultaneously create an idea on her website, the idea on the website wouldn't be able to connect and write to the database until Zoe has finished hers. SQL also offers deferred and exclusive options, and Zoe adds it onto her learning to-do list to dig into these a little bit more deeper in the future. On the next line, Zoe sees a SQL query that's checking to see if there's already an existing record in the database with a name value that's the same as the one she's trying to save. If we remember back to her idea model, Zoe was concerned about repeating herself, so she added in some uniqueness validation. Even though she's trying to create a record with a name of nil, ActiveRecord is still doing its due diligence and checking to make sure there isn't already a record with a name of nil in there, even though that shouldn't be possible with the presence validation. And on the second last line, the database transaction is rolled back because that name value is nil. This is good. It's getting better. Zoe can see that there's a check for the uniqueness validation, but where's the check for presence? And where does this validation failed message come from? Zoe, she wants some more control. She wants to be able to see the methods that are being called and maybe have a little explore along the way. She decides to recreate the validate each method in ActiveRecord validation's presence validator, rolls off the tongue that one, in her lib directory in her Rails Girls application. This is a really cool thing that you can do in Ruby that not all other languages provide you. She adds in a debugger statement so that when she runs the code, it will pause here, and it'll confirm that she's definitely in the right spot. To make sure that this file gets loaded when she runs the console, she has to require it in idea.rb, the same way that the presence file was required in validations.rb. Zoe restarts her console and tries to create an idea with the name of nil. It worked. It stopped at her debugger, and this confirms that this is definitely where validation happens. Although, Zoe doesn't really see any code that looks like a value is being checked. It seems that this class is inheriting logic from active model validation's presence validator. Very sneaky, and also classic Rails. Zoe writes continue and gets the same output as before. New plan. Zoe recreates the validate each method in her same lib directory for the active model validation's presence validator. This method looks like the one that she was looking for. She can see that there's a check for the value.blank at the end, and if value is blank, it's going to add an error to the record. Zoe requires this new file in idea.rb and restarts her console to make sure it's loaded. She tries to create an idea with a name of nil and pauses at her first debugger statement. Continuing this time should lead her to that next debugger in active model validation's presence validator. And it does. Zoe's found the code that is actually what's checking the value of presence. And she's surprised to learn it's not in ActiveRecord. It's in active model. Since she's paused in this debugger statement, she decides she might as well have a little explore in the validate each method. What are the benefits of being paused with a debugger? She checks the record and sees that it's recorder for thread, which she adds to that learning to-do list to figure out what that means. And record.class returns idea. The adder name returns name, which is the one that she added presence validation to. And the value returns blank. Returns nil with value.blank returning true. This means that an error will be added to the record with an adder name of name, a blank symbol, and options, which Zoe confirms will be an empty hash. Okay, so what did Zoe's exploration discover? When she tries to create a record with presence validation, she's going to hit that validate each method in ActiveRecord validation's presence validator, and then hit the same method name in the active model equivalent. Zoe wants to dive a little bit further, though. She wants to be able to see the whole route that a record's going to take going through the validation flow. She decides to recreate all of the files from the Rails source code that she thinks have the most important methods. She starts with ActiveRecord persistence save method, and then adds in the class methods module with the create method, each with their own debuggers. Zoe's expecting that when she runs idea.create with the name of nil, she'll pause at that first debugger statement, which will then lead her to object.save. Surprisingly to some, including Zoe, this will not take her to the save method in ActiveRecord persistence, at least not yet. It'll take her to the save method in ActiveRecord validations, where she's also added in perform validations and the valid method, each, as I'm sure you might have guessed, with their own debuggers. In the save method, she'll hit that perform validations ternary operation, and by the whole end of this flow is expecting to end in raise validation error, which, as you can guess from the method name, might result in raising a validation error. In perform validations, she hasn't passed any options, so she's going to hit the valid method. And then in the valid method, through the call to super, she's expecting to end in the valid method in active model validations, where she's also added in run validations, each with their own debuggers. In the valid method, she'll hit run validations, and then in run validations, she'll hit run validate callbacks. This method is dynamically defined using active support callbacks. Zoe has to do a little bit of digging, but she eventually figures out that she'll end in the validate method in active model each validator, where she put a debugger in just before all of the attributes get looped through. From here, it's finally back to familiar, or at least recently explored, territory with validate each in ActiveRecord validations presence validator, and then we've already got our debugger. We'll hit the call to super and hit the same method name in the active model equivalent, where we already have a debugger. Zoe requires these 4 new files into idea.rb and restarts the console and prays that the video plays. So far, so good. She tries to create her record with the name of nil, and she hits that first debugger in the create method. She types continue, which should take her to the save method in ActiveRecord validations. So far, so good. From here, she should end in perform validations, or land in perform validations, which she does. And then since she hasn't passed in any options, she'll land in the valid method, which she does. So far, so good. From here, we'll hit the valid method through our call to super into active model validations, nailed it. And then from here over to run validations in the same class. Perfect. So from here, our dynamically defined run validate callbacks should take us to the validate method in ActiveRecord active model each validator. There we go. And then from here to the validate each method where she started this journey in ActiveRecord validations presence validator. Perfect. And then it's one final stop to the validate each method in the active model equivalent. From here, Zoe knows what happens. It's the validation failed message. She types continue and is surprised to be back in the each validator. Zoe's a seasoned investigator, so she knows how to check what the attribute is, and is surprised at its name, but actually that makes sense because she did add uniqueness validation. Up next, that validation failed record method. Oh no, still in each validator. Zoe knows what to do though, so she checks the attribute and is surprised to see that it's picture. She didn't add any validation for picture. She continues again and is stuck in each validator. The attribute being checked this time, still picture. Bit spooky. She continues again and is stuck in Groundhog Day. Active model, each validator, still picture. On continuing this time, she hopes that maybe, and yes, she's never been so excited to see a validation failed message. That flow went mostly to plan. Zoe goes back to idea.rb and definitely confirms that she has not written any picture validation. But code doesn't lie. There is picture validation written somewhere. She writes out a command that will print all of the validation that exists on the picture attribute and finds the culprit. That carrier wave gem she added when she started this journey apparently has its own sneaky picture validation in there. Zoe does a bit of digging and discovers that she actually doesn't even need this carrier wave gem and that she can use oh my gosh. Thank you. I almost said active support, and I was like, it's not active support, active storage. She can use active storage now instead. Turns out that Rails guide is a little bit old. She adds remove carrier wave gem onto her learning to-do list and has a little reflect on what she learned. So when she was trying to validate a record, she landed in ActiveRecord persistence class methods create method, which then took her to the save method, then perform validations method, then the valid method, all in ActiveRecord validations. From here, she hit the valid method and run validations method in active model validations, and then active model each validator validate, where she actually landed 5 times, twice for name and 3 times for picture. But she was only really concerned about the presence validation, so she landed in ActiveRecord validations presence validator, validate each, and then the same method in the active model equivalent. This is really good. Zoe feels like she understands the validation flow, but what would have happened if there wasn't a validation error? How would a record be created in the database? Zoe decides that she's going to comment out all of the validation flow, because she knows time's ticking on. We need to get a move on. And she knows how it works. And tries to create a record that's going to be valid this time. From the save method, she should now hit the save method in ActiveRecord persistence, where she already has a debugger from before. And then that should take her to the creator update method, which she's added in with a debugger. In creator update, she's creating a record, not updating it, so she should hit the create record method. The create record method has a lot going on, so Zoe adds investigate create record method a little bit more onto that learning to-do list and adds a debugger inside a block where there's a connection. Zoe has suspicions about what this connection could be, so she wants to pause here and have a little explore. From here, it's one final method, insert record. Insert record, the last method of the day, and therefore one last debugger. Zoe adds discover more about insert record onto that learning to-do list and spots connection.insert at the end of the method. This is the magic or code that actually inserts a record into the database. Okay, one last run through in the console. Zoe writes the code to create a valid record this time because it has a name attribute. She lands in the create method in class methods, continues, and then lands in the save method of ActiveRecord validations. This is where things get new. She commented out the debuggers from the validation flow, and she's not expecting validation errors, so she lands in ActiveRecord persistence save. Now it should be, on continuing, a stop in create or update, which it is. And since we're creating a record, not updating, we should land in the create record method. The suspense, amazing. We're in that connection block. Zoe has suspicions that this might have something to do with what she saw in database.yaml. When she checks the connection, she is excited to find that it is a SQLite 3 adapter, which lines up with that SQLite 3 gem that she saw in the adapter keyword. On continuing here, it should be to the insert record method, the last method of the day. So now continuing should take her to the result of a successful database entry. And it does. Zoe can see that the transaction has been committed and that an idea has been created. Who would have thought creating a record in the database could be so exciting? Okay, that was a lot. Zoe takes a moment to pause and confirm what she has seen. When she tried to create a record, this time with valid attributes, she landed in the create method of ActiveRecord persistence class methods, and then ActiveRecord validation save. This is where the flow got new, because there were no more debuggers in the validation flow, and there weren't any validation errors. she landed in the save method of ActiveRecord persistence, then creator update, and then create record. Here, she did a pause and confirmed that the connection instance was a SQLite 3 adapter, which confirmed that her learning in database.yaml was really important. And then it was one final stop in the insert record method of ActiveRecord persistence class methods. That concludes Zoe's model creation learning. Zoe is feeling like, oh no, sorry, we got a little recap. So, on that weekend, she ran the Rails generate scaffold command that created all of the files that Zoe needed, including that migration file. When Zoe ran Rails dbmigrate, Rails checked to see if the timestamp from the migration file was in the schema migrations table. It wasn't, so Rails created the ideas table for her and then added that timestamp onto the schema migrations table. Then Zoe went into idea.rb, which she saw inherited from application record. In application record, she saw that it was inheriting from ActiveRecord base and learned that that inheritance is what turned what would have been a regular old Ruby class into an ActiveRecord model. Then Zoe landed in ActiveRecord base, literally the base for all ActiveRecord code. And she saw all the records that were extended, included, and required in that file. She could have stopped there, but instead she did a deep dive into the Rails source code and explored methods across both ActiveRecord and ActiveModel. Zoe is feeling like she has a much better understanding of how ActiveRecord is working behind the scenes within her Ideas app and how it comes out of the box with Rails. In her learning of the gem file, she saw that Rails is automatically added to the gem file when you run Rails new, and that ActiveRecord is one of its dependencies. In default configuration, it was in application.rb where the line require Rails/all loads all of the Rails components, including ActiveRecord, via the rail tie. In database configuration, Zoe saw that there's nothing ActiveRecord specific in database.yaml, but it is crucial for making sure that ActiveRecord can connect to the database. And lastly, in model creation, it was applicationrecord.rb that she saw it inherited from ActiveRecord base.rb, which is what turned it into that ActiveRecord model. Zoe also took the opportunity to bring the Rails source code to life within her application and added in a bunch of classes and methods using debuggers to pause the flow and confirm just what was going on in there. She also decided that if ActiveRecord had a best friend, it would probably be ActiveModel. This concludes Zoe's learning journey for today on ActiveRecord. But she still has, oh gosh, the distortion just gets better and better. But she's got a big old learning to-do list of things she wants to learn more about, because the learning journey, it just never ends, does it? Thanks everyone for listening. If you want to test out some of these debuggers at home, you can find the repo on my GitHub account. Hopefully all of you have learned something or refreshed your memory on something, have thought of a new way to pair with your junior engineers, or maybe just are excited to get back into the Rails source code. If you want to connect with me, you can find me on X, so I don't really use it, and LinkedIn, and also just come and say hi throughout the conference. And one final announcement, WNB.RB is a lovely group of women and non-binary Rubyists. If you are one of those people and you'd like to join us for lunch today, you can join us at the front of the stage after the last morning talk. If you already have lunch plans, don't worry, you can cancel those, because it's a 3-day conference and we're only meeting today. So hope to see some women and non-binary folk for lunch. Thank you very much.